Hello, good morning. Now we are talking about the derivations of length formula. What is the formula? 1 by f is equal to 1 by v minus 1 by u. Here f is the focal length, v is the object distance, and v is the image distance, and u is the object distance. All distances are measured from the optic center. Optic center is a point inside the lens at equal distance from the two surfaces on the principal axis. So from that optic center we will measure, and from that optic center, when you take the object towards the left side of the mirror, and from lens, left side of the lens, the object to lens, the light rays are coming. Now against the light rays you take measure, that is all comes as negative, and in the direction of light rays if you take the measure, they all comes as positive. Okay. So now in the lens, object will be towards the left side and image forms towards the right side. So all should take the positive, except only the virtual image which forms at the back of the object, same side of the object. So that only you take as the distance as a negative, but it will the height we take as a positive. So the measures which we take above the principal axis taken as a positive, below the principal axis taken as a negative. This is the height of the image by height of the object is the magnification. These two we will see now, derivation of magnification and derivation of focal length of the lens by deriving the formula 1 by f is equal to 1 by v plus 1 by u.
Say we have a thin convex lens of focal length f and an object of some height h0 is kept at some distance u from the lens, and say we know these values, we know the focal length u and h0. The question is, can we figure out where the image is going to be exactly and what will be the height of the image? So we can draw a ray diagram. Let's draw a couple of rays, and where the rays intersect an image is formed. And so the goal is to figure out what is the height of that image and how far is that image formed from that lens. So these are the two things we need to figure out. And the trick over here is going to be very similar to what we had done when it comes to mirrors. So the idea is we have to find similar triangles which have these as their side lengths. And then we use the properties of those similar triangles to make a relationship between them. So pause the video for a while and see if you can find some pairs of similar triangles in this figure. Alright, if you look carefully, then you will see these two are similar triangles. Let's see how. If you look at this angle over here, that must be the same as this angle. They're vertically opposite to each other. Then they have this angle equal to this angle because they are both right angle triangles. And therefore the other angle must also be the same, making them similar triangles. And also notice the side lengths are exactly what we want. And so now we can say that their sides are having the same ratios. And therefore, if you take this height and divide by this height, so if you take hi and divide by ho, that should be the same as the ratio of any other side. And so we can take this now. That should be the same as v divided by u. So that's equal to v divided by u. So we have found one equation over here. And this one equation contains both the unknowns. We don't know hi, we don't know v. So we can't use this we haven't found our answer yet. So we need another equation. So we have to find another set of similar triangles. And if you couldn't find them before, then again, I encourage you to pause the video and see if now you can find another set of similar triangles. This time, try to find one which has f in it as a side length. Again, if you look carefully, you'll find these are similar triangles. Again, one angle is 90 degrees. They're both equal to each other. Then you have these vertically opposite angles which are also equal to each other, which means the third angle must also be the same, and as a result, these two triangles are similar. So we can write a similar equation for these two triangles as well. Their heights and their side lengths are also in the same ratio. Again, pause the video and try to write a similar equation for these triangles. All right, let's do that. Again, if you take hi divided by this height, which is the same as ho. So if you take hi divided by ho, it has to be the same as this length. Well, what is this length equal to? Can you see that this total length is v, and this is f. So this is v minus f. v minus f divided by this length, which is the same as f. And that is equation number 2. Now notice that we have two equations with just two unknowns. And so we can eliminate them and we can figure out what is the height of the image and what is the image distance. So the geometry is done, and now all we have to do is algebra to eliminate the variables. And if you look carefully, you will see that they have the same left-hand sides, which means we can directly equate their right-hand sides. Again, one last time, try and pause the video and see by equating them, the right-hand sides, if you can come up with an equation very similar to what we got for mirrors. All right, let's do this. Let's make some space. We don't need the diagram anymore. It's just solving the two equations. Okay, so the right-hand side, we can equate them. So v divided by u has to be equal to v minus f divided by f. And now all we have to do is make this equation a little bit pretty so that we can remember this. Okay, so we'll get rid of the denominators. We'll multiply the whole equation with u and then with f. So we get v times f. The u cancels out, and over here the f cancels out. So we get v minus f times u. So just cross multiplied. And for the simplifications, let's just simplify. V times f equals v times u. We'll just multiply this, minus f times u. Now to make this equation look pretty, just divide the whole equation. Divide the whole equation with u, v, and f. So let's see what we end up with. On the left-hand side, v and f cancels out. So you end up with 1 over u. Let's write that down over here. So 1 over u equals, here v and u cancels out. So we are left with 1 over f minus, over here f and u cancel out, which means we are left with 1 over v. And if we add 1 over v on both sides to make sure that this looks similar to the mirror equation, we can now write 1 over f equals 1 over v plus 1 over u. And there we have it. That is the equation that connects the focal length, the object distance, and the image distance. Okay, and similarly, once we know v, we can now substitute this in any of the two equations. We can substitute over here, and we can now find what the height of the image is. So just like what we did for the mirrors, we can define this thing called as the magnification m, and that is defined as the height of the image divided by the height of the object. That's the definition of the magnification, height of the object. It tells us how much is the image magnified compared to the object, and that turns out to be, as you can see, just v divided by u. v divided by u. That's the second equation. So let's just bring these two equations to the top. Since we derived this equation for this specific case where we had a convex lens and where we got a real image, these equations may not be general equations. They may not work for other cases where we might get, say, virtual images or where we have a concave lens. So what to do? Well, we have tackled this situation before. The answer is sign conventions. We've seen before that if we treat these distances as positions on a graph, and if we write these equations with signs, then they end up becoming a general formula. And that's exactly what we're going to do over here as well. We're going to use the same Cartesian sign conventions, and we're going to put signs over here, and we're going to generalize them. All right, just like before how pole of the mirror was chosen as the origin, now we're going to choose the optic center as the origin, and then we're going to choose the incident direction as positive. Over here in this diagram, the right side is the incident direction, so that becomes positive direction, which means all the positions to the right of the origin are positive positions, and all the positions to the left of the origin are negative positions. So we have to put these signs over here. All right, so if you look at this equation, let's start with the focal length. Focal length is the position of the principal focus, and that's over here, and that's positive, so this stays positive. The image distance is the position of the image, which is also on the positive side, so that also stays positive. And object distance is the position of the object that's on the negative side, so that becomes negative. And so positive times negative, well, that becomes negative. So our final equation, general equation, is this. Now this, we can double box it because this now has automatically become the general equation. And that's the power of sign conventions. Now this can be used for any case we want. All right, let's generalize this. Now again, for sign conventions for the height, we're going to choose above the principal axis as positive height and below the principal axis as negative height. So let's see. The height of the image is negative height because that's below the principal axis, so there's a negative sign over here. The height of the object is above the principal axis, so that stays positive. V is the image distance, so that's the position of the image, that stays positive. U is the position of the object, that stays negative. Now remember, the magnification M is defined as HI divided by HO, not negative HI by HO. So this is not our final equation. We need to get rid of that negative sign from the height. And if you look carefully, the two negatives cancel out, which means this itself is now the general equation. Because this now, we have used sign conventions. So this is general equation. So these are the lens equations, which are very similar to the mirror equations. The only difference between them is the sign of U. If you flip the sign, if you make the U negative, you end up with mirror equations. Just check that.